.toString. Alrighty, let's see what happens, shall we?
I'm excited. I'm hoping we get 3 points.
All right, now let's try moving this over. Oh, you know what I forgot to do?
What's that?
Increment my score. Score plus plus.
You even had your comment in there for it too.
Increment score. That meant the overall process, which the UI is so essential, but so is the other, right?
Yeah, you can't forget to increment the score, yeah.
All right, so let's move this guy over here. 1, 2, 3. Easy enough. These exact same concepts we just did right here, where we read input, move an object. Typically, you'll actually see this done in fixed update.
Why are we doing it in fixed update?
So, update calls per frame. If your game is running 40 frames a second, that's running 40. This code is getting called 40 times a second. With fixed update, the physics engine in Unity works at a fixed time step, which you can define in Unity. I think it's 0.02 of a second, so 50 times a second it runs. And because physics, they need a consistent value to do it in. So this method gets called basically 50 times a second. It's a fixed time, and that's good for physics. There's rules sometimes we can use one or the other. I cover that a little bit more in the MSDN magazine article because sometimes you want linear motion, sometimes you want scaling motion, so one's good for one, one's good for the other. But typically, anytime you move a rigid body, I should say often, you'll see in fixed update.
Makes a lot more sense now.
So now, these same concepts here, colliding with an object and moving an object and updating the UI, they are essential concepts, which will bring us to, when we create our game, piecing all the elements together. But first, people are going to notice when I run this game, they're going to say, all right, this is a 2.5D game. We're talking about 3D here. How do I run around in a 3D world? And I just want to show this real fast because it's so essential to understand the options that are out there. So that's going to bring me to something called character controllers. And if I go to my Unity project, the same one I was just using, I'm going to disable that camera. And I have brought in Unity's sample assets, it's called. Right here. In the asset store, you can download sample assets. And there's an AI character, AI car. They've got this little first-person and third-person controller. So I just imported that into my project. Once I did that, I can come over here under standard assets. Under sample assets, characters. Now I could do a first-person controller, and I could just simply, let me find one of my cubes so I can place this right near my cube. I can drag and drop this guy right here. Run my game.
Oh, we have a game.
And I have footsteps. I don't know if you can hear those or not. I can jump. So I can do that with a first-person controller. I can delete my first-person controller. I could come in here with a third-person controller. And I could run around with that third-person controller as well.
And these assets are really great just to bring in and take a look at to see how they're actually building these assets.
Now you'll notice the funny thing is I'm reading input on the cube, and my characters are reading all of my full input. That's why you see both of them running around. And look at that guy runs into the cube, knocks him around. So really, really cool things you can do easily. Since you want to get up and running in a game fast, I highly recommend downloading those asset packs and checking it out. For what we did in this next game, Zombie Pumpkin Slayers, we kind of wrote our own code on there using the exact same principles that I just showed in that demo scene there. Exact same principles. So first, let's cover what we did on the title screen here. So our title screen that we did, let's run the game here so you can see it. You guys are going to see the game now. At least we'll see the title screen first. We'll slowly unveil it.
It's always the best way. You can't give away everything right away.
Give away everything. You got it.
It's kind of my favorite music track too.
I love the feel of this music for this game. It's just
Zombie
right.
Surfer dude.
Zombie Pumpkin Slayer. We've got this animation going on here. Got some UI elements here. When I click on this button, my scene will load. So before we do that though, let's just kind of do a walkthrough here. This is nothing more than some UI elements placed out here. Let's go like this to unveil what this really is. Remember on that last level, when I added a text box, it added a canvas element for me. That's what this new UI system does. Any UI elements add this canvas here. So what's a UI element? If you take an image and drag it on your screen for what Carl was doing, for example, that's a sprite running around on the screen. That's not a UI element, typically, although it can be. When I think of a UI element, think of a heads-up display in a game. You've got a score in the upper left-hand corner, and it shows you your power-ups in the lower right-hand corner. That's, to me, that's a UI, a GUI system. They're fixed on the screen, although they don't have to be. With the new UI system in Unity, they can follow characters around. You can actually have any UI object anywhere in your scene. But for the sake of this, for what I'm doing here on the title screen and for the score and whatnot in the game, I'm using the UI system. And anytime you add any UI component, it creates a canvas for you. Oops, and this event system, which is how it detects what you're clicking on. So under the UI menu, you've got a couple basic things. You have a panel, which is nothing more than an image. You have a button, which is nothing more than an image with text and a script on it. You have text, you have another image. So a lot of these are based off of images. And literally everything I have here, except for nothing, actually, except for this button here. So I've got these images right here. Let's see each one. So I've got my background. Let's zoom in on this guy a little. You can see that bluish image in the background I disable. That's nothing more than an image right here. And early on I talked about a game object being this name and tag and a transform. With the new UI system, you have a rect transform, which is a different object. Similar to the regular transform, but this is fixed more for 2D. You have a whole anchoring system on here that you can anchor things in the corners so they will stretch with the screen. Very similar to what you'll find in Visual Studio for when the new .NET stuff came out and the new Windows Forms and XAML, how you can take elements and dock them in there. Very, very similar to that.
So I can dock elements inside of other elements as well then?
Dock other elements inside of elements, inside of other elements, inside of other elements, make them all scale out in front of each other, do some really cool things there. So these are nothing more than images with a script on here, which basically just says, hey, what source image is this? And it's just a sprite in our scene. When Carl was doing the character animations, they were just sprites. These are just sprites assigned to this script. Same thing all down the line here. We've got Pumpkin Row, right there, those pumpkins. We've got the Blue Glow, just nothing more than a glow. Blue Glow. Pumpkin Row.
That sounds like a band.
I know, I was thinking
Pumpkin Row.
Now you've got Skid Row stuck in my head. Thanks. We got the logo, Zombie Pumpkin Slayer. Notice here, we can set, if we want to stretch, see how it's stretching with it and it's growing?
Oh, that's beautiful,
because
too.
I've set that in the horizontal direction. I want to expand. I can expand in horizontally and vertically if I want as well. So and down here is a button, which is nothing more than an image and a script on there. With these scripts, it can detect a click and call a new method. There's a couple different ways of doing this in the UI system. And also, you can have different transitions. So when you mouse over your button, you can play different animation. These are just 2D animations, just like Carl showed in the 2D session. And they will create these for you. When you basically create a new button, let's just create a new one to see this here. UI button. If I go to animation,
look at that.
Auto-generate animations. If I click on that, it says, hey, what animation names do you want this? And it'll create them all for you. So it's real easy to do. And the button, again, is nothing more than an image with a button script and a text component underneath. So real basic components that make up this UI system to do some powerful stuff on there. Now, when you click on the button, again, there's a couple different ways to do this. In my button script, I'm saying, this game object, I want you to send a message to it. Send a message. And again, there's several ways to do this. I can think of actually 3 off the top of my head. A direct reference. You can hook into this event in code. Actually 4. You can use your event system, or you can specify a method here. So this send message function says, give me the text of a function name on this component. So it exists in code somewhere on here. Let's open the code. This function is what I'm going to call when you click on the button. So let's go back to that. This here is going to call the play click button. The play clicked method, I should say. And in order to load a new level, in other words, load a new scene, they should probably call this load scene. It would make more sense to somebody first learning this. You give the name of your scene. Now that scene has to exist in your build. File, build settings.
With a check mark next to it.
Yes, file, build settings. This is where all the goodness happens. This is where you can select all your platforms. It's also Control-Shift-B if you like hotkeys. It's the same hotkeys Visual Studio. And in here you can say, I want this platform, set that as my default. These are all the scenes here. You don't have to have them all in here.
Ooh.
You can kind of keep them all pretty simple if you want. Let's do this here, remove a bunch of these. And actually, just to show you this is how the empty dialog box is right here to start. I can add on the current scene. We've got that one, okay. Now I've got the title scene in my build. Any other scenes I want, I can just take those scenes, maybe drag them into here. And that's
Pretty
it. So
cool little shortcut there.
these are the names of the scenes that must exist in order to call that code. So I need a title or arena, Atom main. Now let's run this guy. So we have our title screen. When the game runs, we'll click on that. It calls application load level. Now we get to unveil. What do we get to unveil?
The actual game itself. You guys ready for
Zombie
Pumpkin
Slayers. All right, let's look at this. Now, let's kind of dissect all this out here. Before I do that, let's make sure we get the right slide here talking about this because this is of epic proportions. We don't want to miss this. Demo, creating zombie pumpkin slayers. This is going to be the gameplay aspect of it. This is going to model all of the basic components that we just looked at with those cubes. It might look complex-ish. Let's run this and see what happens. Actually, let's make this bigger when we run this. So you can click maximize on play. Let's run that. So we created this over actually the last few days. We had a bunch of different ideas. So these guys come up to the tombstone here, and they try to attack it. There's some particle coming out of that tombstone. There's randomly spawning pumpkins here. They're playing different animations. And your job is just to keep smacking the heck out of these pumpkins that are here. Let me eliminate these real quick.
What an awesome set of graphics on here as well. Talk about the power. Cool lighting effects.
So the Matt is the, I did all the code integration behind this. Matt is the mastermind behind, of course, all these graphics on here. So let's pick this apart here. Let's see what we've got in this scene. We've got more guys coming here. This is what I was talking about way, way earlier though, so I can just show you while I'm here. We can do per frame advancing here. You see my little guys running, each little frame there. So if you need to do fine grain debugging, you can use that a lot. Okay, so let's pick this scene apart. We have a world that's a 3D model. Let's go in the wireframe here. You can see it's kind of these little, it's a little bit dark in there, so we can see in the background here, if I go like that, actually, let's do textured wire. So we've got a level. You can buy these off the asset store. You can make them yourselves. We're going to talk about this a little bit in the optimization session tomorrow. We've got more 3D models that are just kind of plunked in here. If we look at this guy here, just a mesh render.
Pretty simple,
that shows us. Very, very simple. Our pumpkins are just also meshes. And they have a little controller script. They have a rigid body on them, so they're on the ground, moving across the ground. They have a pumpkin controller. It's got a speed. And I simply have a variable defined here for hit colors. If you notice when I was hitting it with a hammer, it would flash a color. And when the pumpkin gets smashed, we play a particle system. Remember I showed earlier, real quick, I did a particle system. So this particular particle system I used on here was part of the Tune FX pack, which is a really cool particle system on there. You can find some free ones and pay ones on Unity Asset Store, some really neat ones. And I basically say, hey, I need a reference to a particle system I want to play here. When this pumpkin starts up here, we find a couple components. So this pumpkin has animations. We need a reference to our animator component. That's going to control what we're going to animate, what we're going to do. I need a reference to my renderer element. Well, what do we do with our renderer element? We're doing nothing more than flashing a red color. That's why we need this component. Now movement, I'm just a little caching a reference here. Sometimes we'll cover this in optimization section. It's best to cache certain things, saves on what's called garbage collection and allocating memory later on, sometimes if you do things up front. We'll talk about that again more in optimization section. I have a game controller object in my scene. Game controller is just essentially a near empty game object. It has no visual properties. And a game controller you find in a lot of games. It's a script, an object in your scene that has some code methods responsible for doing something. It's kind of like the coordinator in your game. In this game, this one is responsible for updating the UI for a score, exactly like we saw on the cube demo. And we have some random stuff, some random spawning.
It's kind of like the orchestrator.
The orchestrator, yes,
There we go.
exactly. Now our pumpkins, let's click on this pumpkin here.